In this lesson, we're going to look at how to write a double replacement reaction, and sometimes this is also called a precipitation reaction. So let's just get right into an example. Let's look at the first one. I'm going to rewrite it a little bit bigger. In a double replacement reaction, like the one here, you will have two compounds that are reacting together, two ionic compounds that are typically in solution. So in this case, I have AlBr3, aluminum bromide, reacting with AgNO3, which is silver nitrate. What's nice about double replacement is, over single replacement, is that if you remember, if you watch the video on single replacement, you have to know which two elements you're switching based on what you're comparing in your activity series. For double replacement, you don't have to check whether or not this occurs. Just right away, all you do is you take the two positive ions, or the two metals, or the two guys in front, the two ions in front, and all you're doing is they are switching places. It's called a double replacement because two compounds get new partners, essentially. So the two things that I've just underlined here, I am not combining them together. I am switching places. And I'm going to create two new ionic compounds that I will write as products. Whenever you're getting the formula of an ionic compound, you've got to look up charges, switch them, and make them subscripts. And again, if you need any review on that, I have a separate video on writing ionic compounds. So aluminum was with bromine. Now aluminum is going to take the spot of where Ag was. So what is aluminum combining with? Aluminum is combining with nitrate, NO3. So somewhere on the side of my paper, I want to do a little scratch work. I want to write aluminum with its charge, Al3+, and I'm combining with nitrate. That's a polyatomic ion, so you might have a table to look that up in, NO3-. And when I switch them, I get the formula AlNO3, 3. That is the formula that I am going to be writing as one of my products. So I can't just write AlNO3. I don't know what the ratio is until I check the charges. Notice as well that when I'm forming ionic compounds, whichever is my positive ion is staying in front. Aluminum was in front to start with, it's still in front. And whatever's my negative ion comes second. And I should make sure that when I'm making an ionic compound, I'm always combining a positive first with a negative. I never want to combine two positives, they would repel, or two negatives, they would repel. So that's another way of kind of checking your work as you go. So again, the Al and the Ag, the two ions in front, are switching places. Al's now with NO3, what's Ag going to combine with? Oh, Ag is going to combine with Br. If I look up Ag, it has a +1 charge, so again, keep that in front, and Br has a 1- charge. And if I switch them and make them subscripts, I just get AgBr. So that's the formula of my second product. And it doesn't matter which of these products you write first or second. That's completely up to you, as long as both of these things are on the right-hand side of the arrow and have a plus sign in between them. Now there's two other things to finish this reaction. One of them is when we're writing a double replacement reaction, we should really put in the phases of our products. Also, because a lot of the times a question might ask, what's the precipitate? And a precipitate is a solid product that's formed. So in order to do that, we need to know the solubility, or be able to check the solubility of our products. And this might be something, depending on your teacher, that you have to memorize, or you have a table. For my grade level chemistry class, we will use table F. So if I go to table F looks something like this. And I just put the products at the top to remind myself what I'm checking. So essentially what I want to do is, if I notice, just kind of looking at table F, this first column tells me all ions that are always soluble, and anything that's listed as an exception would make it not soluble, meaning it would make it insoluble. Okay, and then if I look at the other side, all these ions listed here are typically insoluble, unless it's combined with one of these exceptions that would make it the opposite, that would make it soluble. So what I want to do is I want to find the part of my ion in either this first column here or this first column there, and then check what it's combined with. So let's look at our examples. AlNO3. If I peruse down, I don't see Al. I don't see Al. All right, let's check the second ion. Let's check NO3. Do I see NO3 anywhere? Here's NO3. There are absolutely no exceptions, so that would be a soluble ionic compound. And let's check the solubility of AgBr. If I peruse down here, I don't see Ag anywhere by itself, but I do see Br. Here's Br. Though it's in the soluble list, Ag plus is listed as an exception, so that would actually make this insoluble. Okay? Typically, when you're writing a double replacement, or what's called a precipitation reaction, one of your products will be insoluble. In this case, it's AgBr. So how can I indicate the solubility with phases? Whatever you pick being soluble, you are going to write as AQ, meaning that if we're starting in solution, that particular ionic compound would still stay dissolved in solution. If something's insoluble, what that means is it will not mix into the water. It will drop to the bottom as a solid. So the phase would end up being a solid. So again, if something's soluble, we're going to write aqueous. If something is insoluble, we're going to write S for solid. And I know for some people that seems backwards, because when you see an S, you want to think of starting with an S like soluble, but a solid means it's insoluble in water. So if I come back here, the AlNO3, we are going to write aqueous next to it, and the AgBr, we're going to write solid. So we now have our phases. If I were to ask you what's the precipitate, your answer would be AgBr. It is the solid product. It would drop to the bottom. And then if you wanted to, you could put in phases for your reactants as well, and eventually it's something that would be good practice to do. Typically your reactants are going to be aqueous. They're going to start in solution, and if either of these things I checked on table F, I'd find them both being soluble. The last thing I want to do is I want to check that I have a balanced equation, and right now I don't. If I notice, I have 3 nitrates on the right, and I only have 1 nitrate on the left. So I can balance that by putting a 3 in front. Now I have 3 silvers, so I want 3 silvers there. And now I have 3 Brs, which would balance. So that's how you write a double replacement reaction. Let's do another one for practice. I'm going to give number 20 a try, and I'm rewriting it over here. So calcium chlorate reacting with sodium carbonate. So again, all that's really going to be happening is my 2 positive ions, or my 2 guys in front, are going to end up switching places. Somewhere on the side of my paper or in my head, I've got to figure out what the new formulas are going to be by looking up charges, switching them, and making them subscripts. So calcium was with ClO3. Now it's taking the place of where Na was. And calcium is going to be combining with carbonate, CO3. So if I look up calcium, that has a 2+ charge. Carbonate, CO3, has a 2- charge. If I switch them, I get Ca2CO32, but what can I do with those subscripts? I can simplify. Remember, for ionic compounds, we always want to write the simplest formula. So one of my new products is CaCO3. Make sure that the positive ion's first, the negative ion second, and then I've combined 2 things of opposite charge. If not, I'm doing something incorrect. Okay, Na was with the CO3. Now it's taking the place of where calcium was, so it's combining with chlorate, ClO3. So if I look up Na, it has a +1 charge, so the positive should go first. Chlorate has a 1- charge, that should go second. And when I combine them, I get a 1-to-1 ratio. So there is my second product, and I will write them in. I don't care which one comes first and which one comes second. That is totally up to you. Okay, let's put in our phases. So let's go check the solubility. So CaCO3, I might not see Ca by itself anywhere, but here's the carbonate ion, CO3. It's insoluble. Let's check the exceptions. Group 1 means the first column of the periodic table. Calcium's not on the first column, it's group 2, so it's not an exception, so this is insoluble. And NaNO3, or NaClO3, excuse me, it doesn't matter which thing I check, I can actually find both of them on here. Here's Na, it's in group 1, always soluble, or I could have looked up the chlorate part and saw it's always soluble. I should get the same answer no matter which part I'm checking, so this would be soluble. So let's go add in our phases. Remember, for insoluble, we're putting a solid, and for soluble, we're putting aqueous. So CaCO3, we said was our solid, and NaClO3 was aqueous. And again, just really going back to emphasize, if you have an ionic compound, you really do have to simplify, or it's going to throw off your balancing later. So now let's just check if we have a balanced reaction. Okay, there's 2 NAs on the left. We need 2 NAs on the right, and that will also balance my chloride ion. Questions? Let's just do one more example really quick. Let's do this last one, number 21. So I just rewrote the reaction. I'm going to take my 2 positive ions, or my 2 ions in front. NH4 is a +1 charge. That's a positive ion. And the Pb are switching places. So on the side, I'm going to look up charges. I'm going to switch them. I'm going to make them subscripts. I'm going to figure out what these new formulas are. So NH4 was with Br. Now it's taking the place where Pb was. So what's NH4 combining with? NH4 is combining with nitrate, NO3. So if I look up NH4 in my polyatomic ion table, it has a 1+ charge. NO3 has a 1- charge. So when I take those charges and switch, I get a 1-to-1 ratio. I get NH4, NO3. Make sure I've combined a positive and a negative ion. Make sure my positive one's in front. Let's do my second compound. Pb was with NO3, now it's combining with Br. So Pb, if you look it up, it does have more than 1 charge. Make sure that you keep whatever charge it had to start with in my reactant side. So if I look at my reactant is PbNO3 2. So what charge did Pb have? Pb had to have a +2 charge, because if I look up NO3, that's a 1- charge. There's 2 of them, so that's a 2-. So Pb would have to be +2 so that the charges equalize and cancel out to make a neutral ionic compound. So whatever the charge of an ion is to start with, that's what's going to be the same charge as the product. So this is Pb with a 2+ charge. And again, it was with NO3, now it's combining with Br, which has a 1-, and when I switch them, I get PbBr2, okay? And I will write both of these as products. I don't care which one you put first or which one that you put second. Just again, remember, whatever the charge is on the left-hand side, you must have that same charge on the right-hand side. So now we just got to look up our solubility. And if I do that, NH4NO3, no matter which part of the compound I look at, both of those are always soluble, so that would be aqueous. And if I look up PBr2, I might not see Pb by itself, but Br is insoluble when combined with Pb2+. It's an exception, so that would be solid. That's my precipitate. If I wanted to, I could look up my reactants. Typically, they're going to be aqueous. They don't have to be, but they usually are. You're really starting with 2 ionic compounds in solution. Okay, same thing even with this reaction above there. I could have looked those up. And lastly, we just need to balance. So I have 2 Brs on the right. I should have 2 Brs on the left. And now I have 2 NH4s, so I need 2 NH4s on the right, and that balances my. So that's how you write a double replacement reaction. If you notice 22 through 25, instead of giving you the formulas to start with, I might give you words to start with. Sodium sulfate. Okay, sodium is Na+, sulfate is SO4 2-. If I switch them, I get the formulas. Okay, and it's reacting with barium chloride. If I look up barium, it's 2 plus. If I look up chlorine, it's 1 minus, so I get BaCl2. And then I'm in the same starting place as I was before. So you might see names instead of formulas, and you can still feel comfortable. You just have to look up charges and switch them a few more times to get in the correct starting position.